So for reviewing the linear programming test, imagine for a second that you just had to graph x is less than or equal to 50. Take a second. We're going to process what that looks like. Make a sketch of that. All those critical skills. It might have been x is like donuts. I went to a thing on the weekend where we had donuts, we had cookies. Okay? And less than or equal to 50. Did you use a line like that? No, because that would have been y is blah, blah, blah. Did you use a line like that? All right, did you have to shade? Which way do you shade? To the left. Should it be solid or dotted line? Solid. When would you ever use a dotted line? Yeah, if it was just less than. If it was just less than or just greater than. All right. Okay, next, on that same graph, I'd like you to graph y is greater than or equal to 1/2 x. I know you won't know exactly how steep the slope should be, but you should be able to think about, like, the y-intercept and the slope, and I know which way to shade. Did you remember I went through 0 for the y-intercept? And if you made it really steep, you kind of missed the point. That would be like a big slope. This is a small slope. You go over, you rise and run, right? You only rise a little and you run a lot. So it should have been fairly flat. Not flat, but less than a 45-degree angle. All right, and then you should shade up. Now, if this is about donuts and cookies, so x is donuts and y is cookies, then what other constraint equations would you have to put in the list? There was most of you remembered, but a few of you forgot. Brandon, what's one or two of them?
Y and x are greater.
Just one thing at a time. Y?
Y is greater than or equal to
And
x is greater than or equal to
there you go, good. And that tells you that it has to be on this side of this line and that side of that line. So then where does it all get shaded in? Like the dark part, the feasible region. Go ahead, darken in what you think the final answer is. And I know you're attracted to that triangle. That is not it. The triangle you see is not it. Why is the triangle there not it? Well, because the shading above the green line, that means that if you're in here, you're going in the wrong direction. The shading is not towards that. All right, so you should have shaded in this area right there. Now, would you agree that it keeps going up? Like it doesn't stop. It just keeps going up. So in that kind of problem, would we ever ask you for the maximum profit? No, because it keeps going forever. When are you gonna what points are you gonna pick? What we could ask you for is what is the lowest cost, like looking for a small number. All right, and given that, this and this would be your two corners you'd have to check, the vertices of the feasible region. Do you get that a lot of people on this test picked that number because it seemed like it was a corner of the feasible region? Don't raise your hands because that would be embarrassing. But there's like 8 people in here who picked a spot that wasn't on the feasible region. And no, you can't pick that one. Even if it's got the lowest number, what's not one of the feasibles? You'd have to pick from the spots that are on the corners of the shaded shape. All right, there's a quick summary. Now, I think one of the hardest things is actually writing equations, though, and that's something where it's going to require me to tell you a little story, and I want you to write the equation for this. Just write the equations. I think you know how to graph them. I think you know the feasible region. All right, so here's the story. This one's gonna be about tickets to a play, and it's a classic example because everybody understands, okay, there's adult tickets and student tickets, and the adult tickets are more. So let's make X be the adult tickets, and Y is the student tickets. Can you write me an equation for this then? The adult tickets for this play are $25, and the student tickets are $10. No, you can't actually write an equation yet, but it's important to know, so you should probably write it down. I'll say it one more time. The adult tickets are $25, and the student tickets are $10. That alone does not make an equation. You got X, and you know that it goes with 25, and you got student tickets are 10, so those goes with Y, but I haven't told you anything that you could use to make an equation yet. This one, a lot of people mess this one up, so be careful. We sold 500 tickets. Now, if you really think about it, you'll do it right. But if you just kind of go, oh, 25 goes with the X, and 10 goes with the Y, and it equals 500, you're not really thinking about it. Because, see, this was money, and this was money, and that's not money. So that equation would not work. If you really think about it, you can't have money plus more money and have it equal not money. These are people. So it should have just been X plus Y. Raise your hand if you had just X plus Y. Okay, good. Now, if I told you how much money we made, let's say that we made $800. Now, write the equation. If we made, not like we grossed, as in not the profit, but just our gross. We grossed, we made this much money total for that night. We made $800 that night. How do you write that equation there? That's the one where 25x, 10y, $800. Because look, money, money, money. It matches up. That make sense? Okay. Then where would the optimizing come in? It's another set of data. So let's say that we know that when we sell all these tickets, we don't all make this all as profit. Like, you don't just walk away and say, ooh, we made $800. No, you had some expenses. If you're doing a play, you might have had to pay for like some costumes and some set design and all that stuff. And let's say after a lot of like work, you figure out that on the adult tickets that you typically make about $5 profit. But only $2 profit on the student tickets. If I said, hey, I need to know what maximizes our profit, you could write an optimization equation. It doesn't get graphed. Write the optimization equation. All right, you should have said 5 for each X plus 2 for each Y. And I had a few people just leave it like that. What's wrong? It's not an equation. It used to say equals. Is it an equation now? No, it has to have something on both sides. So like P for profit. That's an equation. It's got an equals and something on both sides. All right. So there's a quick reminder of the linear programming unit. It was short. That's why I don't have to drone on and on up here. It was a fairly short unit. Okay. And then the other one was a matrices test. And given that we have a few kids taking that test, obviously I'm not going to talk about that today. Now, what could you do in class today? Well, this time we have a actual Schoology quiz to help prepare you for the cumulative. The cumulative is not tomorrow. It's the next day. It's on Wednesday. So I want you to open up and start that Schoology quiz today. And if anybody wants to, I can hand back your linear programming test, and you can look at it. If you want it to count the cumulative, to count as a retake, you have to do corrections. It's not that hard, and wouldn't you wanna know what you did wrong the first time? I think you probably would. That's why I make you do corrections on it. It's not that hard. Just take a separate sheet of scratch paper and fix it. All right. So I'm gonna leave it up to you now. You have a bunch of time to work. And you got this Schoology quiz. It is due. It does count. Counts in the grade, so do it. You get 2 tries at it. You don't see it? Okay, hold on. In a moment, I'm going to stop my video here. In a moment, I will open that up so everybody that's at home will definitely see that Schoology quiz. And you get 2 tries like usual. You get the answers after the first try. And you get the average of your 2 scores to prevent kids from just putting in junk answers and getting 100% on it later. You get an average of your first try and your second try. All right, that's all I got for you for the video for today.